The next generation of Backtrack has arrived. The big surprise? It's no longer called Backtrack. Welcome to Kali Linux. Let's begin. Our objective for you and I in this video are simple. We want to be able to describe what exactly is Kali Linux all about, what are some bells and whistles and features it has, and how do we get it actually installed and up and running on our computer. Let's do a little history lesson in Backtrack. So Backtrack version 1 was developed back and released in 2006 into the wild. And then there's version 2 and 3 and 4 and 5. In fact, Backtrack version 5 was released in 2011. Then we have Backtrack version 5, release 3 was out in 2012. And you might be saying, well, Keith, what exactly does the history lesson in Backtrack have to do with Kali Linux? And the answer is, Kali Linux is the next version of Backtrack, except they're dropping the name. So instead of calling it Backtrack version 6, it's simply going to be referred to as Kali Linux. And that announcement happened in March of 2013. So one of the questions for a lot of people is, okay, should I start using it, or is my old Backtrack still good? The reality is, if you're currently using Backtrack version whatever and it's working for you, that's fantastic. If the tools inside of it work for you and they're doing great, there's really no need to change or migrate or update to the new software. However, one of the things that I've noticed with a lot of Backtrack utilities is that they haven't always made it successfully between versions. For example, we go from version 3 of Backtrack to version 4, and some of the tools just stop working. It's terrible. So one of the benefits of this new implementation with Kali is that they're doing a Debian compliant packaging of the tools. Two things that'll give for us. Number one, it'll be easier for people who write tools to recreate packages and actually get them working. And secondly, the tools that we get as users are very likely to work more often than they did in the old Backtrack arena. So the environment as a whole is going to be more successful with the tools that are packaged with Kali Linux. Another benefit that I think is really cool with Kali is that we can customize the installation. Maybe we don't want to use GNOME. Maybe we want to use a KDE. Whatever look and feel you want, you can customize that ISO, and you can actually install from a repository. That could be a local system, or it could be off the web. Won't be as fast off the web. But those are some of the traditional features that we'd have in a enterprise environment if we're rolling out distributions of Linux. Those are all now available in Kali. Another really important benefit is going to be cleaner and smoother upgrades. For example, let's say we're running Backtrack version 4. We'll go back in the time machine a little bit together. So we're running Backtrack version 4. We have our favorite set of tools that we're using, and then there's a new version of Backtrack. So we say, great, we want to upgrade, and unfortunately some of our tools don't work anymore, and it's pretty much a rewipe of the entire system to implement the new Backtrack. Well, with Kali, when we have major upgrades, that transition, theoretically, should be a lot smoother, and because everything's Debian compliant, including all the tools and the packaging of those tools, it should make for a better overall experience for you and I, the users of Kali. Now, there will be some people who say, you know what, I'm using Backtrack at the moment. I'm going to keep on using that. It works well. And others are going to be upgrading or start over with Kali. And here's the great news for you and I, is that virtually all of the tools that you and I have been going through in these nuggets together, those tools apply to either distribution. So you haven't lost a thing regardless of which platform you decide to use. Very similar to Backtrack, we can either run Kali from the live CD without installing it to the hard disk, or we can choose to install it to the hard disk and boot and run it from there. So let's walk through a real quick install just to compare and contrast that install to what we experienced with Backtrack. In order for us to install this software, we need to have access to it, and we can download it from this URL right here, www.kali.org. In the downloads folder, we'll select the details regarding what we want to download. Now, at the moment, they only have version 1.0, but we can specify the architecture we're going to run this on, 32-bit, 64-bit, ARM, etc. Windows Manager, at the moment, they currently only have GNOME, but if we wanted to customize an ISO and use KDE or something else, we certainly could. It also has a SHA-1 checksum for us. Now, this checksum can be very handy in the fact that it could validate the integrity of that file. Like, for example, let's just imagine that for whatever reason, we got tricked into going to a wrong site to download it. So we download it, and it's a malicious copy, meaning somebody's made their own distribution. They've added some additional quote-unquote tools, some backdoors into it, and we're about to download it and install it. It'd be good if we knew about that. So what we might want to do before we install this image to our computer We might want to use a separate machine or a separate website just to verify what the actual checksum, what the hash is for that file, and then compare it. Now, there's ways of comparing it based on your platform. On Windows, you can download a tool like this one. I actually downloaded the ISO image already. Here's a free SHA-1 verifier tool that I ran, and here's what I did. I said, okay, here's the file that I downloaded, which it is, and I want to do a SHA-1, and I said, go ahead and calculate the hash. And so it did. And then I copy-pasted this guy right here, and I said, go ahead and compare. And I said, okay, yeah, those two match. And because the hash matches, I know the integrity of that file is intact. So by verifying the hash, either using a third-party tool or the integrated tools inside Linux to go ahead and do that, it just gives you an added level of confidence that you have the right image. Now, just as a heads up, what if we went to this website, but we had our DNS redirected? It's not HTTPS. We had no certificate to validate. If an attacker was advertising this download, the attacker could also modify the checksum. So even if we ran the checksum and it matches, it would be bad information from the actual website we got the image from. So it might be a great idea to verify that checksum out of band or from another computer or another system or another website just to verify that the hash that Kali.org has specified for that file matches the hash that you have for that file. That would be the proof that you've got the right file and the data integrity is intact. So let's go ahead and do this install. I'm going to do this on a virtual machine because I want to record the entire process. So to do this inside of VirtualBox, I'm going to go ahead and click on New. It's going to say, what do you want to install? I'm going to say some flavor of Linux, and I'm going to say it's just generic Linux. I'm going to scroll down to the bottom and say Other Linux, and then I'll go ahead and give this a name of CBT Kali, just like that. And we'll click on Next. It's going to ask me a few questions like how much memory do you want to give it? I've got plenty of memory on the system. I'm going to give this guy 2 gigs, just like that. And I'm also going to create a new hard drive for it, a new virtual drive. So I'm going to click on Create. It's now saying, okay, what kind of hard drive file do you need? And I'm only going to run this in VirtualBox. I don't need to go between VMware and VirtualBox. So I'm going to say a VDI VirtualBox disk image. Click on Next, and I'm going to say dynamically allocate the size. Meaning, let's say I say you can have 20 gigs. It doesn't mean he has to take up the full 20 gigs at the very first moment. He can dynamically grow it up to that size. Sounds good to me. It's the default. I'll click on Next, and it's now asking me how big do I want it. I'm going to specify, I can also just type it here. So it's going to type 20 gigs, just like that, and click on Create. So now I've got this brand new virtual machine, but how do we actually link it up with that ISO that I just downloaded? Well, the way we do that is we go to this right click and simply go to Settings. And for storage, we're going to go down to Storage. And here, see how the CD, it says it's empty? We're going to go ahead and we're going to browse for that file, and we're going to go ahead and specify it. This is already in my history because I've already installed this once. I'm going to select the Kali Linux ISO image that we just downloaded. And by selecting the ISO image, now when he boots up, he can go ahead and boot to that device, and we can actually do the install from there. One other thing I'm going to do is I want to also assign, I have that USB external wireless adapter. I want to go ahead and allocate that to this virtual machine. So I'm going to go to USB, make sure that Enable USB 2.0 is clicked, and I'm going to click on Add. And there's a whole bunch of USB devices. I'm going to go ahead and select this guy right here. That is indeed my wireless external USB adapter that I've been using with Backtrack. It's going to work fine also with Kali. Once that's done, I'll click on OK, and we can just bring up this machine by double-clicking on it or by highlighting it and click on the Start button. Either way, it's going to bring up the new virtual machine. Now, from this boot menu, it says, great, you want to run the live CD? We could just press Enter, and it would boot off the CD without any install to the hard disk. Or we can scroll down and simply say, I want to do an install. Now, the graphical install versus an install, it doesn't mean that one's going to get X Windows and the other isn't. The install here is simply going to have a text-based install for all the choices. And then once it's finally installed, you'll have X Windows and all the other graphical user interface benefits that we would typically have as well. So let's go ahead and do the basic text-based install. And it's just going to prompt us for the information it needs as it goes through. So what language do you want to use? Okay, we want to use English because that's my primary language. I happen to be in the United States. Those are defaults. And I want to go ahead and use a key mapping regarding the keyboard of American English, which is the default. We'll press Enter, and it's going to start the install process. So now it's asking, what is your primary network device that you want to use? Is it that wireless network adapter that it sees or the logical Ethernet interface? And I'm going to go ahead and say Ethernet 0. I can use the up or down arrow keys to select that. So Ethernet 0 is going to be my primary connection. Now in this virtualized environment, that Ethernet adapter is bridged to the host machine's primary adapter. So we'll press enter. And it's trying to do IPv6 auto configuration. I don't have an IPv6 active network in place, so that's not going to be too exciting. However, I do have DHCP services running, so it should be able to go ahead and get an IP address. It wants to know what the host name is for this device. I'm going to call it CBT Cali, just like that. I'm going to hit tab. Tab is going to bring the highlight down to here, so now when I press enter, it's going to select continue. So anytime you need to navigate, you just hit the tab, and that will cycle through the various fields. When it's where you want, press enter. It's asking for the domain name, and I'm going to call this cbt.com. Hitting the tab key moves the red highlight to the continue option. I'll press enter there. Now it's asking for a password for root. Now I'm going to use the password of tour just because that's what I have on my backtrack. You can use anything you want as long as you can remember what it is. So after I've typed in tour to set the password for root, I'm going to hit tab one time, highlights continue, press enter, and now it's asking us to verify that password to make sure we didn't have a typo. So if I thought I typed TOOR and I didn't, I would be in trouble. So I'll type in TOOR one more time, one more tab, one more enter, and now it's asking me about my time zone. And I'm in the Pacific time zone. And now it's asking me, okay, I see 20 gigs out there that I can use for hard disk space. Do you want me to use the entire disk? And I'm going to say yes to that by pressing enter. So I'm just going to confirm that that's the hard disk I'm going to install to. If it is, I'll press enter. And then it says, do you want to split it up? I'm going to take the default of putting all the files in one partition by pressing enter. And then I'm going to specify that I want to finish the partitioning of that hard disk space, that logical hard disk, inside of VirtualBox and continue the install. So here's a little summary. I'm going to hit tab to go over to yes. Are you sure you want to write those changes? Press enter. And the installation continues. So now it's asking us if we want to use a network mirror to go online to get updates if they're available for this installation. So I would say if you're connected already to the internet, I would go ahead and say yes to this. So I'm going to say yes. Is there a proxy server involved? And the answer in my case is no. I've got access from this virtual machine through the host machine through to the internet without using a proxy. So I'm going to hit tab one time, press enter to continue. It's going to go ahead and scan the mirror for updates. And so it's out getting additional updates and packages for this installation. That's an awesome feature. It's going to put me ahead of the game compared to all the software coming from a CD that might be a little bit out of date. So it's got its updates, and now it's continuing with the installation. It says, do I want to install the Grub bootloader to the master boot record? And I'm going to say absolutely yes, go for it. So I appreciate the confirmation. So it's installing that for us. And now it's saying, okay, the install is complete. It's time to reboot. I want to point out something that happened. Down here, this is the VirtualBox control panel for this device, this virtual machine. And that being grayed out represents that it ejected the CD. So if I was on a live computer, it would have auto-ejected the CD to prepare me for the boot to the actual hard drive. So if everything's in order, which I think it is, we can go ahead and press enter to continue. So it's doing a little bit of cleanup, and once it's done, it'll reboot this system into Kali Linux loaded off of the hard drive. Okay, so from this menu right here, if we use the up and down arrow keys, we can go ahead and pause. It automatically boots in 5 seconds. But if we wanted to, for some reason, interrupt that, we could. And I'm going to just press enter, and this is going to launch this from the hard disk on the system that we just installed. And in our case, that's the VirtualBox hard disk that's logically 20 gigs on this system. So now that it's installed, we can go ahead and simply log in by clicking and saying I want to log in as root. And my password is tour. And we are in. And here, my friend, is Kali Linux. So the menu is at the top now, applications, and if we go to Kali Linux, they've got the top 10 security tools, and then a very similar list to what we experienced in Backtrack. So virtually all the tools we've taken a look at so far are still included in Kali Linux. In this video, we've taken a look at the next generation, if you will, of Backtrack called Kali Linux, some of its features, and how to do a basic install to get it up and running. I've had a fantastic time here with you. I hope this has been informative for you, and I'd like to thank you for viewing. If we come across the need to analyze the nitty-gritty detail that happens between a browser client and a web server for whatever reason, we simply are curious, we're trying to troubleshoot something, or we're looking into a vulnerability that might be happening on either side, we can use an amazing tool set called Burp Suite. Let's begin. I'd like you to go back in the time machine with me and remember that moment when you first learned about the TCP/IP protocol suite. Pretty awesome stuff. We have the application layer up here with things like FTP and HTTP, etc. And then we have the transport layer with things like TCP and UDP. And then we have the internet layer where we have IP. And then we have the data link connection and the physical down here. So there's the data link and then the physical, where we actually transmit the bits, whether it's over fiber, over copper, over radio frequency, we're sending out those bits in some fashion. Well, let's talk about an HTTP application. Now, we know that when a customer sits at a computer and they type in www.cbtnuggets.com, they press enter, what do they expect? And I know they expect some fantastic training that's entertaining and engaging. Besides that, they expect a response from that web server. So the actual program they're running invokes HTTP, which gets encapsulated in TCP, and that gets encapsulated in IP and it gets sent off. Now, TCP has this three-way handshake that it does and all that magic. But you know what? There's a lot that goes on at this application layer. A lot of HTTP requests and methods. And when we go to a single website, we can have actually dozens of TCP sessions being established to pull down that content so we can view it on our computer. Now, how does that relate to the world of penetration testing and security testing? Well, if we are building a web-based application, or we want to check to see the security and the details of a web-based application, we need some visibility into the specific calls at the application layer with what the heck is really going on. One amazing tool that is free and it's included in Backtrack and Kali is something called the Burp Suite, or as its friends call him, Burp. Now, you got to be pretty brave to name your product Burp, but this is an amazing product. There's two flavors. There's a free version, which has a lot of the functionality, and then there's also a professional version where you can purchase a license for it, where it unlocks all the additional bells and whistles. But here's the basics. It is a web application security toolkit. It has a proxy functionality. So here's what we do. So here's our Backtrack machine, or it could be Kali, either way. And we're going to run Burp Suite. So we launch it here, and it's a proxy. Now, what does a proxy do for a living? A proxy takes requests from clients and forwards them onto their final destination. So what we do is we run Burp Suite right here on our Backtrack system, and then we open up a browser on the same computer, and we tell our browser, we're not doing a man-in-the-middle attack on somebody else, but we're actually taking our own browser and telling our browser to go ahead and use Burp Suite as its proxy server. So any traffic we generate will intentionally go through Burp Suite so we can analyze it. We can see all the requests, the replies, we can pause it, we can intercept those requests, we can replay them back in different manners to test the response and the reaction from the web server based on different types of requests going out. So it's an absolutely awesome tool to have in our tool belt if we want to look at the nitty-gritty details for HTTP. So let's imagine we've opened up a browser, we're going through the Burp proxy on purpose on that same Backtrack system, and we look at the results and we say, oh, look at these, 4 or 5 different possible branches that we could go off on. If we wanted to, we could click on one of those branches, one of those sub areas, if you will, of the website, and we could turn on the spider function. The spider is going to crawl across the web. Now, specifically, it's going to crawl in the area that we told it to, and that is going to create quite a bit of request on our part. So we're making a whole bunch of requests that are going to enumerate or elaborate on the details in that area of the website or websites. There's also another really cool feature called a repeater. And the repeater, you can take a request that you've captured and say, you know what, I wonder what would happen if we change these 3 or 4 characters or these variables. And we can actually replay it back with those changes So for the benefit of seeing what a tiny change in an HTTP request would make based on the response we get back, that's a fantastic tool as well. There's also a scanner function, and that's included in the professional edition. There's also an intruder option, and there's a few other bells and whistles too. Our objective in this nugget is to give you an exposure to this tool and a sample of what it can do and how simple it is to go ahead and use. So let's do a demonstration of Burp. To find it, we're going to open up Backtrack and go to Vulnerability Assessment, Web Application Assessment, and then down under Web Application Proxies. And you know what? Truth be told, you're going to find this in a couple different locations based on the fact that it does multiple things. So besides just on Web Application Proxies, we could also go to Web Vulnerability Scanners, and it is there as well. Either way, it's the same Burp Suite. So we're going to launch it. Now, in Kali, it's going to be in a slightly different location, but you'll be able to find it there as well. Once you launch it, the very first time you run it, it's going to ask you to accept the end user license agreement for Burp Suite. You're going to click on yes, and then you're presented with a menu like this. Now, there's lots of tabs up here. They're going to be very important. Let's go up to proxy. Now, by default, this guy is acting as a proxy server. So what that means is any clients, like a browser on the same machine, who points to this proxy server is going to have all of its traffic sent through this device. Now, it's sort of like a man in the middle on purpose, because we want this device, the Burp Suite, to be able to intercept those commands and then forward them if we want to. We can also change them before we forward them. So by default, intercept is on. And what that means is that your clients, every single request they make, it's not going to be proxied out to the internet until we click on the forward button. So that's very important, because no traffic will flow unless you turn intercept off by clicking that, or if it's on, you click on forward to forward the actual request. Here are the options for the proxy, and by default, it's going to be listening on its loopback interface on port 8080. That is right here. So if we have a client running on the same Backtrack system like Firefox or some other browser, we need to set the settings on that browser to point to the loopback on this system still and port 8080. That's to make sure the traffic actually gets to Burp Suite. So there's really not too much else we have to do here by default. Let's go ahead and bring up a client. And by default, we've got Firefox and we've also got Konqueror. I'll launch Firefox. Virtually every browser has an option for a proxy setting. So on Firefox, to find that, it's under Edit and Preferences, Advanced, and then under Network, and then Settings. And based on the browser that you're using, the proxy settings may be in a slightly different location. So in preparation for this, I set it already to use a manual proxy, point to the loopback address of this Backtrack system on port 8080. And what that means is all requests from this browser are going to be sent through Burp. And so Burp will now have the opportunity to intercept each and every call, and we'll have to manually forward it or turn off the intercept mode. So now that that's set up, let's go ahead and launch something. Let's go out to cbtnuggets.com. I want to make sure I don't get anybody in trouble. So I'm going to go to cbtnuggets.com. Now, see how it's working? It says waiting on cbtnuggets.com. The reason it's not coming back right now is because Burp Suite is not allowing it. If we go over to intercept here, this is the actual request. How cool is that? This is the literal request coming from that client. If we want to forward it, we'd click on forward right here, and that forwards that request out to the final destination. So in the background, the client, our own client, our browser, would now get the response from that. So I've gone to one website. That's all we've done so far, but there's lots of objects on that page. If we want to see the details of that, we go up to Target, and this is a list based on what we just did. Well, wait, Keith, let me make sure I'm clear. You went to one website, and yet you have all this information. The ones in bold here are literally pages that I hit. Now, I know I only clicked on cbtnuggets.com, but there's a lot of activity just on that one website. The parts that are in gray represent the fact that we didn't actually visit those sites literally, but we're aware of those sites because of the page that we're currently on. So to analyze this, let's say we click on cbtnuggets.com. Over here on the right, it'll give us all the details of what it actually saw. And check this out. This is the request. So here's our request. We can scroll up and down. And here's the response. Now look at this. On the response page, there's a tab for render. And that means if there was a graphical representation that came back, we can actually see it right here. So we can go ahead and simply click on render, and it should show us any graphical images that were on that page. Sure enough, there's a whole bunch of really fun people. There's James Conrad, Jeremy Chara, Chris Ward, and others, including myself up there on the right. So that's a fantastic way of actually seeing. Now, this is just for fun. You don't see the graphic, but we can also see the HTML code. We can see it in hex, the headers, see the raw data for the response. So there's the request, and there's the response. Now, let's say we wanted to change something. If we wanted to, when we initially did that proxy and we had that request, we could have changed content there and then forwarded it to modify that data. But let's say we're trying to play with some parameter or some variable and seeing how that's going to affect a website or a web page. Here's how we could do that. We have all of this history. We can simply go and say, you know what, I wonder what would happen in this request here if I changed this from Firefox 14.01 to Firefox 13.00 or something else, or some other parameter that was actually being sent. To replay that, to actually replay this back to the server, here's what we do. We're going to right click on this guy and say, I want to go ahead and I want to send it to the repeater. And all it's going to do, this tab up here, I want you to notice this tab right there is going to go ahead and go highlighted, meaning there's activity happening there. So I'm going to say send it to the repeater. We have repeater highlight. The repeater tab goes highlighted. We click on that, and now check this out. This is our initial request. So if we want to modify this here at all, for example, let's say we say it's a GET, and we'll say it's HTTP 2.1. Now, I'm not an HTML programmer by any means. So let's go ahead and click on Go, and that's going to submit that up to that web server, and then here's the response that came back. So it looks like me changing that made very little, if any, difference. However, as we're doing testing and application development with the new website, or we're trying to discover new ways of getting that web server to respond to us, we can manipulate virtually anything we want to in the data that's being sent and take a look immediately at the reply back in real time. Another really cool feature is the ability to go ahead and do spider. So for example, on CBT Nuggets, everything that's bolded was actual pages that we hit and got information on. If we scroll down and we have something, for example, licensing, and we wanted to get more information on this, we can simply right click, say go ahead and spider from here. It's going to say, well, this is outside your current scope. Are you sure you want to go for it? And say yes. And take a look at this. The spider tab highlighted, indicating it's actually going out and gathering additional information. So it made 39 requests. It got that much data back. And if there was just a really big site where it was crawling and finding all the additional details, it could go ahead and you could have queued up requests based on your specifications of how many requests at the same time can be outstanding. So down here under YouTube. Now YouTube, it's not bolded, which means we're aware of the link. We haven't actually searched it yet. If we wanted to add and get more information about that, we could just go ahead and search it with a right click and say spider this host. It's going to go ahead and start spidering that. Now up here, this spider tab, how it's now yellow or was yellow for a moment. If we click on that, check this out. This is, again, this is not very quiet. We've made that many requests. We've had that much data transferred. And this is how many requests are queued. And this is going to keep going until we've walked that entire branch, which could be absolutely huge. So we might want to go ahead and pause that. So I don't really want to walk the entire branch off YouTube for that. However, if we go back to Target, all that additional information is going to show up for us as well. A couple other options that might come in very handy. As far as scope is concerned, you can specify what you want to see or not see in the scope. So if you want to focus on specific elements, you can do that. Also, if you go back to the actual sitemap over here, you can also filter this content. If we want to filter this content, we simply click right here and we can specify, okay, I only want to see certain types of data. And that way you can fine tune and look for specific elements in that HTTP that you're interested in. In this nugget, you and I have answered the question, what tool can we use to see the nitty-gritty detail that happens between a client browser and a website? And how can we manipulate those requests and then see the exact response based on those changes? And the answer, my friend, is Burp Suite. It's included in Backtrack and Kali. It acts as a proxy. It's not intended to be a man-in-the-middle attack, but more of an analysis tool so we can strategically go to websites and content that we want to and analyze the responses that come back from those servers. I've had a great time. I'm glad you joined me. I hope this has been informative for you, and I'd like to thank you for viewing. Kali Linux running on a Raspberry Pi. Oh my goodness, when I first heard about this possibility of running Kali Linux on a Raspberry Pi, a computer that's small enough to fit in your pocket, I was blown away. And I'm so excited about sharing my findings with you and the success I've had in using Kali Linux on a Raspberry Pi. Let's begin. I'd like you to imagine that you and I have decided we want to have a dedicated system for our pen testing. And to do that, we have a couple options, really. Number one, we could just take a laptop that we aren't using for any other purposes and just load Kali or Backtrack on top of that and use that. That would work. We could also take our existing laptop that we're using for our operating system like Windows or Linux, whatever it is, and we could dual partition the hard drive and then boot to one or the other based on our need. But you know what? There's another really great option, and that is to use this little gem called a Raspberry Pi. Now, the Raspberry Pi has been around for a few years, and it's starting to make a lot more traction as people are getting very, very creative with applications they can use a Raspberry Pi for. What is it? Well, effectively, it's a computer. Now, take a look at these ports. These are two USB ports right here, and there's one on top of the other. And so there's two USB ports. This is an RJ45 connector for an Ethernet cable to connect to your local area network. This is HDMI for video output. Here's a micro B USB connector, and that's how it's powered, by the way. And if you have like an old phone charger with a micro B connector for USB, and that, my friends, is how you power it. There is no power supply that comes with it. This computer that we're looking at right here is powered by that micro B USB connector. So you'd plug that into your computer or USB hub, or even a typical phone charger with a micro B connector very likely has enough power to support this entire system. When I first discovered that there was an image of Kali Linux written for the Raspberry Pi, I thought to myself, oh my gosh, I'm going to buy one. And if it works, I'm going to go ahead and make a nugget out of this. This is too good to be true, because we could create one of these things for like under $50 and have these little, penetration systems lying around the network wherever we want to plug them in. So if you wanted to have them specifically in a wiring closet or some other area of a network, they are fairly small, and all they need is USB micro B connector to power the entire thing. So the next challenge is, okay, Keith, I'm interested. What exactly does it take to put this all together? And that's our next challenge is, what are the ingredients to make it work? Well, I went out. I like Amazon.com. I'm in the U.S., and they've been very, very good customer service to me. I like Amazon Web Services. I like a lot of things about Amazon. So I went out and I bought one at Amazon, and I got this flavor right here. I just put the details in case you want to replicate it. It's a Raspberry Pi. That's the dimensions of it. It's Model B, revision 2.0, 512 megabytes of RAM. And I have never worked with the Raspberry Pi before. I mean, I've seen them at the CBT Nuggets office. They have a competition about clever ways of using Raspberry Pis, but I'd never actually touched one before. So I ordered it. It came in. I opened it up. And here's what I ordered along with it. I ordered a wireless adapter, and I also put the details for which wireless adapter I got. Now, why did I buy this specific wireless adapter? It was like less than $12 US for the wireless adapter. And the reason I got this was because at Amazon, when I purchased the Raspberry Pi, said, oh, by the way, people who usually buy this too. So I bought this 8 gigabyte Class 10 SD card. And I also put the model number there for you in case you want to mirror this exactly. And these are the 3 items I bought. I also purchased a case for my Raspberry Pi. So with the case, it looks something like this. So here's the HDMI cable plugged in. There's the micro USB. There's the Ethernet card. And there is one of the USB connectors in. And then there's another USB below it. So that's the 4 items I purchased. The case, the Raspberry Pi, the wireless, and the card. Now, I also had another 32 gig SD card lying around. I tried it with that, but I had terrible results. And so I wanted to share with you the exact details of what got working to hopefully save you the hours and hours of time that I had in my attempt. So the ingredients include a Raspberry Pi, an SD card, and this is the exact one I got. A keyboard and mouse. I simply had a couple lying around. So I'm using USB keyboard, USB mouse. I didn't have to buy those. I also had the micro B cable. So what I'm using a telephone charger. Now the actual specifications are 700 milliamps at 5 volts. And that's what it says it needs. So if you have any adapter that really does perform at that level, for example, the little dongle that charges an iPad, and a lot of other USB adapters are going to have that amount. You just look at the actual case and see whether or not it will output at least that much. But this is the actual minimum that's required to provide power supply. I also had, as I tested this, I also hooked up another passive USB hub and plugged in 3 additional devices just to verify that it would all work, and my goodness, it did. I also added the USB wireless. Now, the USB wireless I have that I've been using in this series for the actual Backtrack, that also works, but I also have this one because I wanted to have my Backtrack with its wireless and the Raspberry Pi with its wireless at the same time, and these have both been successful in my testing. You also need to get the image that works with the Raspberry Pi. And this part was a little bit interesting in the fact that the first download I got, which I thought I got exactly the right image, it wasn't correct. It didn't work successfully. So let me take a moment right now and share with you exactly which image I got from Kali.org's website and the one that's working for me right now. So here's the URL that I discovered that had the image that worked for me. So the URL is cdimage.kali.org, and the image that I downloaded that worked was this guy right here. Kali Linux 1.0 armel-raspberrypi.image.gz, and then I extracted that compressed file. And you can do that either on a Macintosh or a Linux using traditional commands, or if you have like a WinUnzip program on Windows, that'll do it as well. And then I simply use that file as my image for my Raspberry. Now the next question is, okay, Keith, once you have that image, how do you actually tell the Raspberry to use it? Well, you see this beautiful SD card right here? Here's what I did on my Windows machine, and there's probably other ways of doing it. So on Windows, I use this tool called Win32 Disk Imager. I did have to download it and install it to do it, and I browsed for the location of that image file that I had just expanded or decompressed, and then I specified here the drive, the logical drive letter that represented my SD card. Now I triple checked just to make sure I was pointing to the right drive letter for this guy and not one of my other external hard drives, because once you click on write and it goes for it, it's going to wipe out the target and put that image on that device. I then clicked on write and it wrote it. That took like 4 or 5 minutes to complete. Once it was done, I simply took this right here, this SD card, and I plugged it into the Raspberry Pi. So then, with my keyboard and mouse connected with 2 connections there, my Ethernet cable, the HDMI, I did not yet connect the actual power supply, which is the micro B USB connector, because I didn't want to have it powered on when I put the hard drive effectively in. And I took this SD card, and on the bottom on this side, there's a slot for it. I simply inserted it, made sure it was seated, and then I plugged in the power supply, the micro USB connector, and it powered up. And I was absolutely pleasantly surprised when it did work. Now, why do I say when it did work? The very first time I tried this, it did not work for me. I had a comedy of errors, and I want to help you avoid those. What I would strongly recommend you do, if you want to do Kali Linux on a Raspberry, is I would first go up to the actual address just by telling it what you want that source IP address to be. So let's go back to the capture and take a look at the results. I let that run for a few seconds. There's like over 2,000 packets that it captured. If we want to filter based on this, we know that the destination we're looking for is 192.168.1.1. We can simply take the destination column, and you could scroll through it, I suppose. That'd be one way of finding it. But a faster way would be to right-click on this and say, I want to apply as filter and select that destination address. And then just go ahead after I select it here and change it up here. So instead of 19, we're looking for 1. It's still a valid filter. And then go ahead and click on apply. And that should show us only the packets with a destination address of 192.168.1.1, which is right here. So if we scroll this down just a little bit, so let's move this over just a little bit, and let's take a look right here. I don't know if you can see it very well, but right here in the output, it has our payload. So that was the actual payload inside of that ICMP message. And again, there's no rules. You can specify virtually anything you want to send out, and Scapy will be happy to do it for us. Another really good thing to be aware of with Scapy is how to get out, and it's Control D, as in I am done. Control D will take you out of the interactive command line interface, and that'll put you back at the command prompt for your Linux box. So let's kick it up a notch. We're going to run Scapy again. Previously, we worked with a single command to send a packet, but we can actually take additional variables and assign all the details for layer 2, layer 3, and layer 4, and then combine them all together and then send them out as one packet. The first thing I'd like to do is we're going to declare some variables. I'm going to create 3 variables, one called L2, and you can name them whatever you'd like, one called L3, and one called L4, and I'm simply telling the system that whenever I refer to the variable named L2, we're really talking about Ethernet. So all we're doing here, these are the variables I'm declaring, and I'm saying, okay, whenever I refer to L2, you know that I'm really referring to Ethernet. Whenever I say L3, I'm referring to IP, and whenever I refer to L4, I'm referring to TCP. And then as we start adding details, for example, we want to specify the layer 2 addresses involved, or layer 3 addresses, or layer 4 port information, we can refer to L4 as the variable, and it will know we're talking about TCP as an example. Just as a quick check, I'm going to type in L2, L3, L4, and it's simply showing us what those represent. So we said L2 represents Ethernet, that's what's shown here, L3 represents IP, and L4 represents TCP, just to validate what our variables are representing. So what do we have so far? We've got something called L2, a label, if you will, a variable that represents Ethernet. We have L3 representing IP and L4 representing TCP. But what are the defaults inside of SCAPI for Ethernet, for IP, for TCP? And to see that, we can just do an L2, which represents layer 2 Ethernet, and a show with parentheses and nothing inside of them. So this command right here says, okay, for Ethernet, the default destination address is a broadcast, and the source is nothing by default, and the actual Ethernet type is not set to anything specific by default. So we could manually set anything we wanted to inside of that layer 2 information. So for the type, for example, if an Ethernet frame was carrying IP, we would set it to hexadecimal 800, which represents, okay, the next layer up is IP. And it would be a different value for IP version 6. It would be a different value if it was 802.1q, etc. If we wanted to verify what the defaults are for IP, we could just say L3, that's our variable name, period show, and then parentheses, open and closed, with nothing in it, and that will show us all the details regarding IP. So IP is representing IP version 4, that's what that means. Type of service is not set, length, ID, flags, fragment, TTL, protocols IP, checksum is none, and then source and destination are simply the loopback addresses, again, by default. So what we could do is we could go in and specify any one of these fields inside of the IP header as we craft the quote-unquote perfect packet that we want to generate and send on the network. So we can manipulate anything at layer 2 and anything at layer 3. Before we start setting any of these fields to the values that we want to use, let's also go ahead and take a look at the defaults for TCP. So to see that, we say L4.show with a open and closed parentheses. So L4 represents TCP. The show command is saying show us everything that's currently set. And here's the defaults it has for everything in the TCP header unless we specify something different. So if we want to change any one of these, we can. We can modify layer 2 information, layer 3 information, or layer 4 information. And the reason for changing any of these parameters might be just to validate a policy, validate that traffic is responded to correctly, or in an attempt to discover some vulnerability or abnormal reaction from a device when we send a specifically crafted packet. So let's work our way up the protocol stack. Let's specify a specific source MAC address that we want to use in a packet that we're going to send. So we're going to say L2, which it knows means Ethernet, layer 2, and we're going to say Ethernet, the source is going to be 0123456789AB. And that's the source MAC address we want to use for the packet we're going to send out. Now, is that a problem if that's not our real MAC address? The answer is it depends on the network. If the network is verifying layer 2 source addresses, and if that's not really your layer 2 source address, it could be stopped by the network. But many networks are not going to stop you if you have an additional MAC address. So from a switch perspective, it would say, oh, there's another source MAC address on this port. It would simply add it to the list of layer 2 addresses that are reachable off the port that your backtrack, or in this case, the Kali machine, is connected to. I'm a big believer in configuring something and then verifying that it actually took correctly. So how would we verify this layer 2 information? We use the same command we did earlier. L2, that's our variable name, .show, and then open and close parentheses will show us everything. And take a look. Previously, we had the broadcast address and we had all zeros here. And now it's specifically showing us that layer 2 address we specified right here that we want to use as a source layer 2 address. Let's do the same kind of treatment for layer 3. Let's go ahead and specify for layer 3, that's our variable name, that for IP we want the TTL to be 99. We want to go ahead and specify the destination IP address of 192.168.1.1. And then we can verify that that took as well by simply doing the L3.show, open and close paren. And that will show us all this stuff that's set for layer 3. And if you'll notice, this changed. What we specified was the destination, but it also is going to use our source address of this backtrack/Kali system as the source address by default when we specify a destination. And that's why it filled in both fields. If we wanted to spoof the source address, we could manually specify the source address here, and that would change the source from what our real IP address is as well. Again, that's how we create a specifically crafted packet that matched our needs for our testing. So let's say we made a mistake. We said, oh, that's the wrong destination address. How do I undo that? Well, we simply use the delete option. So delete and then in parentheses L3.dst. That will remove it. And if we want to put a new destination address back in, we can do so. And of course, it would be a great idea to validate that it actually took. Now, the part of deleting this I just did for demonstration, because if we specified a new destination address, that would actually overwrite the first one that was there. But I did want you to be aware of how you do the basic navigation of setting the variables and then deleting them if you don't want them, and then how to change them. For layer 4, let's also modify that. We'll specify that the source port is going to be 6783, and we'll specify the destination port is 22. We'll set a flag just for good measure. And then to validate that, we just use the L4 show again like this. And there's our source port, there's our flag, and there's our destination port, just to validate that those three elements all got set. A quick way to validate what we did set. Now, we had a delete, we had some adds at layer 2, 3, and 4. To validate that, we just type in L2, L3, L4. And what it's showing us is the values we've set for each of the options within those variables. The source MAC address, the time to live, the destination IP address, the source port, the destination port, and the flags for each of the layers respectively. And again, you don't have to use the actual names of L2, L3, and L4. I thought that would just be nice and convenient to remind you of exactly what we're looking at. Before we send this packet off on its way, let's go ahead and start a brand new capture again. So I'm going to say I don't want to save the old one. I'm going to continue without saving. We're going to start the new capture. I'll minimize that as it's capturing. And let's go ahead and do a send. Now, a send is how we actually sent that initial packet earlier, but now we want to send the L2, L3, and L4 information as part of the packet, and that packet has been sent. So in our wire capture, as we go take a look at it, we should be able to see the exact details that match our layer 2, 3, and 4 information on the packet that was sent. So in Packet Tracer, how do we find the packet with sorting through these 2,000 plus packets? Again, the easiest way is to put a simple filter on it. We'll right click on a destination address, say apply this specific destination IP address as a filter, and then go ahead and simply modify the filter and specify we're looking for 2 in this case, because that was the destination address. And then click on apply, and that should show us just the single packet. So if we open this up at layer 2, it should show us a source MAC address right here of 0123456789AB, which it does. That's fantastic. So there's our source MAC address right here. It should show us the destination IP address of 192.168.1.2, which is right here, which is perfect. And as we take a closer look at the TCP information, we should have a source port of 6783, which is right there, a destination port of 22 for SSH, and the flag should be set to A, which is right here for A for acknowledge, and we can actually open that up just to verify that as well. But it effectively says the same thing. There are a boatload of options and potential applications for Scapy. Let's go ahead and get out with a Control D. Again, that's how we exit. And let's go back in one more time. Let me show you one other option that I think you'll be interested in seeing, and that is using it as a sniffer. Some of the syntax inside Scapy, because it's written in Python, takes a little getting used to. But once you start working with it and you have some familiar commands you use over and over again, you'll be more comfortable from practicing with it. So what this command is saying, I want to sniff on Ethernet 0, and effectively, I want to show the output as it comes up. So anything that this interface sees, Ethernet 0, is going to be displayed to the screen. So let's go ahead and press Enter. Now this, what we're looking at, is kind of a vicious circle because I have an SSH session open over to the Raspberry Pi running Kali Linux. So every time it sends information back to me, that's traffic. It has to report on that over and over and over again. So to stop this, I'm going to do a Control C. And that stops it. And here it has information on all the packets that it saw. So if we scroll up or down, it's going to show us the details. For example, here we have Ethernet header for this packet, and then here's the IP, and then we have TCP, and then it shows us for all the packets that this Kali box actually saw. It also has at the bottom, if we scroll back all the way down, it has a little summary. It saw 332 TCP packets, 4 UDPs, no ICMPs, and 1 other. Another way of doing that same sniff but not having it show all the details is to use the option of summary. So instead of x.show at the end, we put x.summary, and I'll put all these commands again in the Nugget Lab download area for you. So if we hit Control-C now it's showing us how many packets it saw, what type they were, and it also has a summary of those packets that it displayed to the screen. There's also the really cool option of setting up a filter. So we can tell Scapy, you know what, don't just show everything you see. That's too much. Go ahead and only show it to me if it includes this item or the other, which is effectively creating a filter about which information is going to be collected by Scapy. So to set up a filter, it's really quite simple. We're going to use sniff again, and just simply use the word filter and say, I only want host 192.168.1.1, and the 5 says, you know what, only count up to 5. Gather up to 5 of these puppies. That's all I want to see. So when we hit 5, this is going to come back and tell us, hey, you've reached 5, and here's the results of it. So we're going to help it along the way a little bit. Let's just open up another window, and we'll do a ping over to 192.168.1.1. That'll help it. And I'm going to stop this ping, and let's go ahead back to our Kali box, and there we have it. I had 1 TCP that slipped in, and I had 2 ICMPs and 2 others. So now the question is, okay, well, you saw that. That's very interesting. How do we go ahead and view that? And the way we're going to view that is we're going to ask for a summary. So we're going to declare a variable of, we use anything you want to as a variable. I'm going to use A. I'm going to say A equals underscore, and then I want to see a summary. And so here's my summary of those 5 packets that it captured. So here's our 1 TCP packet. It was part of an SSH session. And for the 2 ICMPs, that was right here. And then for the others, they were ARP, which I think is really interesting because the initial ARP request that went out, that's broadcast based. So as the broadcast ARP request goes out, inside of the ARP request, it specifies what IP address we're looking for. And this picked up on it as being a match. And as a result, that's why it made it into our first 5 packets from this request right here. If we wanted to take a closer look, which I really do actually, let's take a look at this guy. So that's packet number 1. So it's packet 0, 1, 2, 3, 4, which make a total of 5. If we want to see the details for packet number 1, we can simply type in A, which is our variable that we defined right here. So we'll say A, open bracket, number 1 for packet labeled number 1, close bracket, and that will show us the details for that specific packet. And here's the additional details on this packet right here, which is the initial ARP request. So it got broadcast out, the source MAC address was this, and inside of the ARP request, the request came from 1.55, the source MAC address inside the ARP request was this. We're looking for the MAC address of 1.1. We don't know the MAC address of 1.1, hence the ARP request. And the reply that goes back should have all 4 fields filled out. So we use an up arrow key and just swap out that 1 with a 2. This will be the ARP reply, and there's the actual ARP reply. In this video, we've answered the question, what tool could we call upon to create a maliciously or specifically crafted packet that we're going to put on the network? And my friend, Scapy can do that and a whole bunch more. I've had an enjoyable time with you in this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.